Cardi B ruined this data quality pattern. There's a pattern called WAP pattern, stands for write-audit-publish, not wet. And like it is how you guarantee good quality data gets published into production. How it works is you write data to a staging table that has the same schema as production. Then you run your quality checks or your audits. And then if the audits pass, then you publish the data from staging into production. And if you just follow this one small pattern that Cardi B ruined, you will prevent 80 to 90% of the data quality headaches that are generated from publishing bad data, such as breaking trust with the analyst, wasting a bunch of time running stupid SQL queries, and many, many other painful things that you will avoid just by implementing this one pattern. So I hope you liked the lecture today. If you want to learn more about how to do this stuff in the cloud, definitely check out the Data Expert Academy in the link description below. I can get you 20% off. Enjoy the course.
What causes bad data? This is not a comprehensive list, but this is a pretty solid one. So logging errors. I'm just going to talk through a couple of things that could happen with logging. One is a software engineer could change the schema of the logs, and then the schema of the logs doesn't match the schema of the table that you are ingesting them into. That usually causes nulls to show up or like has issues like that. You could have different bugs with logging. So here's an example. Say when someone's like submitting a form on a website, you know, when you like click a button on a website, most of the time when you click a button, the button becomes disabled while the form is being submitted. But that's something that the engineer has to code. And if they don't actually disable the button, then you can have logging and data errors because people can double click and then they get two records and it says that they submitted the form twice. And that can be problematic as well. Then, so logging has all sorts, I mean, and I just scratching the surface there on like the ways that logging errors can happen. And that, like, we're not going to go too deep there. That's more covered in the infrastructure track. We're going to cover that in more detail tomorrow if you're in the combined track. Then snapshotting errors. So logging errors is more for fact data. Snapshotting errors is more for dimensional data. Snapshotting errors are actually kind of rare. I think in my whole career, I've probably bumped into a snapshotting error like, I don't know, less, I can count on one hand. So it's like less than once a year do I run into this problem. But generally speaking, like what can happen here is when you snapshot the data, it's you're missing some dimensions or you're missing some users or you have too many users because of the next one down, which is production data quality issues. So in that case is where you have actual bad data in production, like in your production application. So you have data in production, right? That's just incorrect, and you want to you pull it in, and then you have to filter it out or deal with it some way. And a lot of times, those are things that you have to work with software engineers to figure out. Schema evolution can happen both for snapshotting errors and for logging errors, because the logging schema can change in production, and then it doesn't match your table schema. Same with the production table can change and it doesn't match the table in your data lake. Those are problems. Pipeline mistakes, right? Where you have an error in your join or your case when, or all sorts of different pipeline problems that can happen. And then those get into production because you don't follow the contract process that I was talking about earlier. And then here's that idempotent word again, like, and it's going to keep coming up. So you have a non-idempotent pipeline and you backfill, and that causes different errors. And then the last one I think is actually the most common cause is when you are going to release a data set, you don't validate it enough. So, you know, in the speaker series today, when Alex was talking about, he had JD and who was a data engineer he worked with, and there was a lot of back and forth between him and JD when they're building data sets. That's something that you should be working with, or you should be doing a lot with a data analyst or a data scientist. Some sort of like analytics counterpart should definitely be involved in this process. If they're not, like, you're gonna have a harder time. But that's kind of the idea behind what causes bad data. Other things that I think are important to talk about is if you are ingesting data from a third-party API, say you are working with like Salesforce or Slack or Discord or I don't know, Stripe or whoever, third party, right? And they give you an API to ingest data from. They can change their contract just the same, right? And they can mess with you that way, and that can break stuff as well because that's a different contract that you don't have control over. So you have to be especially careful with data that you're ingesting from third-party APIs because that is like you can't just like go and talk to those software engineers and be like, "Hey, change it," because like they're like a company and you have to like go through that process and they're probably not going to listen to you anyways, even if you were able to get to them. So that's a thing to think about. Uh, so bad data, lots of ways that bad data can happen, but what we're trying to do is prevent it from showing up in production. That's the main purpose of this presentation and the main thing that I'm trying to instill in y'all as we go through this. Okay, so we're gonna try something different today. This is gonna be literally the first time I've tried this in the boot camp V1 or V2. What we're gonna do is we're going to split into some breakout rooms, and then we're gonna do four things, right? And this should only take maybe 10, 15 minutes. Where you're gonna go in, you're gonna introduce yourselves, and then you're gonna say how you pronounce those characters there and then you're going to talk about a time when bad data was handled correctly, if you have a time, and then a time when bad data was handled incorrectly, and what happened and like what were the consequences of that. Like whatever you can talk about. Like obviously, don't break any don't get fired from this breakout room or whatever. But that's kind of like what I want to do here. So like hopefully y'all can like get in and meet some more people from your bootcamp as well. So we have validation best practices. So that was one of the common themes I saw from the breakout sessions was like not enough validation rules, and like or like that was the like having proper validation rules was like a good way to handle bad data, and not having enough was a way that bad data showed up more. So this is a great thing, like especially when you're like creating a new pipeline at Airbnb. What they would do is they say, okay, backfill a small amount of data, maybe like a month of the data set, and then check all your assumptions about the data, like the nulls, the duplicates, the enumerations, the time series, the row counts, all of it. Those things should all be in like you should have like a doc of some kind that has a bunch of charts in it that says like here's what this data looks like, and we feel confident in this 1 month, so we can probably backfill the rest of it. And like if it doesn't look good, then you probably want to fix whatever is problematic before you go into the next kind of steps of the puzzle. So that's a good thing to think about as you kind of like go through this process of like finding bad data. Like I found this process to be more on the analytics side, like the data analyst or the analytics engineer is going to be the one who's writing this. Like, because that's the other thing you see on this slide. I say have someone else check all your assumptions. Don't do it yourself. I tried to do that at Airbnb. I remember like when I was releasing like the pricing pipeline, because like the analytics engineer was out sick, and I was like, it's okay. I got it. I got this, right? I'm a good engineer. I'm a staff engineer. I freaking got this. And I totally didn't have it. Like it's impossible. Like if you build the pipeline, it's totally impossible to validate it, dude. It's like I don't get why that's the case, but it totally is. Where you need a separate human to do it. And because I thought I validated everything right, and then I was like, oh wow, I did not, because like you can't like see your own data sometimes. It's kind of interesting and intriguing. So definitely don't break that rule. Definitely have someone else look at it. Okay, so we're almost to the memes. So writing to production is a contract. This is the second kind of big theme of today's lecture and lab. And the contract has a couple pieces to it. So the first one is the obvious one, which is the schema, which is like the columns and data types of the data. Great. But in the data lake, that like in the old world, right, in like Postgres and like relational database world, that contract was like stronger, right? You can do things like put a unique constraint and a not null constraint on your data. And that's pretty cool. In the data lake, you can't, though. All those things kind of go out the window in the data lake because the data lake is just like files. And you don't get the same level of constraints. Like, where, you know, in relational world, a lot of this stuff is the same thing. So you don't have to like really worry about it. But in the lake, you do have to kind of worry about it a little bit more. So you have schema, and then you have quality checks. Quality checks being like row count checks and duplicate checks and not null checks and all the different types of checks that you want to put in your data table. Those need to happen as well. And then the last one is how data shows up in production. And that last piece is the one that is a little bit different depending on the contract that you choose. And we're going to go over, there's essentially two big kind of competing ways of doing things for your, like if you're writing out a data contract. So let's dig into it a little bit. Essentially, we got two flavors of the contract. You have the WAP pattern, which like preceded Cardi B. Like Cardi B like ruined the name, and obviously I had to put Cardi B in the slides because like ode to her. Like she doesn't even I don't think she even realizes how much like of like a data engineering like rock star she is, like by like kind of co-opting that and like taking WAP away from us. But it is what it is, and we're going to be talking a lot more about WAP pattern. And then also there's another pattern called the signal table pattern. So when I was working in big tech, Netflix and Airbnb, they use the WAP pattern, and Facebook used the signal table pattern. And they have pros and cons and benefits and risks and all that stuff. They are a little bit different, and we're going to go a little bit deeper into both of them. So yeah, let's talk a little bit more about WAP. Right. WAP stands for write, audit, publish. That's what it stands for. So write means, if you look at this diagram, you have a pipeline, and it writes to a staging table. The staging table should have the same schema as the production table. Important. Then you run your quality checks. You say, okay, did they pass? If they passed, move the data from staging to production. And then once it's in production, that means that whatever pipelines downstream are ready to fire. Great. There's one more thing here where your quality checks can be what's called blocking and non-blocking. So a blocking quality check is like a very serious data quality issue that you have to troubleshoot. Whereas a non-blocking one might be like more, instead of calling it like a quality issue, it might be more classified as like data weirdness. And like essentially how it works is like, you see, if you follow the path here, it says like, okay, did the quality checks pass? No. Okay, then you fire the alert because there's something weird with the data. And then we say, okay, is the check blocking? No. And if it's not blocking, then we publish anyways. But if it is blocking, then we stop the pipeline and we manually troubleshoot. And we have to figure out like what's going on, because it's worth it to us to do that, as opposed to because even in those cases when you have a blocking check that fails, there can be cases where that's just how it is, and that's just the data. Like I know for sure one of the times that happened for me when I was at Facebook was we had these growth pipelines, and we had a blocking quality check fail because of the fact that like Ethiopia had like we saw almost everyone in Ethiopia leave Facebook, and from our pipeline perspective, it's like, oh, that's a quality error. But then if you look at the world events, you can see, oh no, the world leaders of Ethiopia turned off the internet, and it's like, okay, well then it's not a quality error. It's actually like the actual data, right? So then you have to, and then so in that case, it was a blocking check. We troubleshooted it, and we're like, well, that sucks for Ethiopia, but this is not actually a quality error. And then we exchange the partitions and we go on with our lives. This is write-audit-publish. It's like my favorite. I like this the most. I think that Facebook does it wrong, and I think that Netflix and Airbnb do it right. And this is the pattern I like. We're going to talk a little bit more about the signal table pattern, and we're going to actually kind of alternate between the two slides because I think it will really clearly illustrate the differences. So here is the signal table pattern. In the signal table pattern, how it's different is there is no staging table. You see, the pipeline writes directly to production, and then we run our quality checks on the production table, and we get the same blocking thing. But if the quality checks pass, what we do is we have a thing called a signal table, and the signal table tells the downstream pipelines that the data is ready to go. So what it means is the downstream needs to wait on the signal table, not on the production table. And if you do that, like this pattern is, I mean, obviously if we jump between these two, you can see that the signal table pattern is it's a simpler pattern, right? But it comes with a lot of kind of trade-offs and risks. One of the things that I do not like about the signal table pattern is that it does not cater to ad hoc queries very well. Because say you have your pipeline, it runs, it writes directly to production, and then it fails the quality check. And then a data scientist goes and queries production, because the data scientist is not going to look at the signal table. They're not going to do that. Like, that's freaking madness. Like, the data engineer might look at the signal table, but the data scientist and the data analyst is going to query the production table. And like, there's a good chance that like if the quality check fails, they're going to query production that has bad data in it, or it's going to have data that's incorrect in it. So that is like my biggest beef with the signal table pattern, even though I also recognize that it is a simpler pattern and it actually uses less compute and less I/O. So in some ways it is more efficient in that way. So let's talk a little bit more about like the pros and cons of each sides of this contract. So write-audit-publish, one of my absolute favorite part about write-audit-publish is there's no chance that data in production gets there without passing your quality checks. It has to pass the audit step to show up in production, which is beautiful. That's like, and then so that means that like if you have an ad hoc query user who is querying your production data, they get the same guarantees as the signal table people do in the signal table pattern, which is great. And like obviously you don't even have to worry about signal tables. You can just work with production tables, and they can be your signals for your downstream pipelines, which is a lot more intuitive. Write-audit-publish has a minus. The minus being you have that partition exchange where you have to move the data from staging to production. You actually have to like, depending on you, sometimes you can do like if you're in S3, you can do a partition exchange and it just moves the file, right? Or it moves the folder. It does like a folder rename. So you don't actually move anything. You just like rename the folder, and like the data doesn't even really move. So that could be powerful, but like most of the time there's going to be at least a couple minutes delay when you're doing write-audit-publish versus signal table, because of the fact that you have that exchange step that does take a little bit of time. Obviously, signal table, essentially the pros and cons are flipped. Signal table you have is faster. It's going to hit SLA more likely, and the data is going to land sooner, going to be more readily available. And then I already talked about the cons, like the ad hoc data scientists could end up querying bad data, and it's not intuitive. And like data engineers might not end up waiting on the signal table. They might wait on production, and then they're going to pull in bad data. The idea here, guys, is it's a contract. And like you can see how these two have their different contracts, and like how the handshake is done and the implications of that handshake are not the same. And so that's a thing to think about, like as you're kind of going through your processes of building out your pipelines and stuff like that. So how does the contract look, and like what are the benefits and risks? Personally, I like write-audit-publish. Signal table, not as good, but it has some benefits. It has some marginal benefits that are obviously I listed out here. So let's talk about what happens if these contracts are violated. So most of the time, if you have a non-blocking check, it's fine. But like if you don't obey the contracts, like say you write a pipeline that doesn't do write-audit-publish, then you get bad data propagation. And bad data propagation is literally one of the worst things in the entire world. Like it's literally man, one of the very big issues here. So let's talk about what I mean by that. Like bad data propagation, like pipelines write output data, and then a lot of times that data is then read in by other pipelines that then output data. And you have like a kind of a tree like that, right, where you have like it keeps writing out, and it's great. It's one of the things I love about big data. It's a crazy tree thing, right? So if you have a pipeline that has, say you write a pipeline and then the only downstream is like a dashboard, then the consequences of bad data aren't very large because there's just the dashboard, and an analyst might look at it and be like, this data is funky, and then that's it. As you work with more and more critical data sets, things get more complicated. Like, for example, like when I was working in pricing and availability at Airbnb, those tables had over 1,000 downstream pipelines. So if I published bad data, then that bad data would then get picked up by 1,000 pipelines, and then that bad data would then be like, for my bad data would now be in 1,001 spots. So that's a problem, right? And like essentially, as you create data sets that are more and more critical to the business and more heavily used, the more you need to do this, the more you need to publish good data and follow these contracts so that like you can have all the quality checks in place so that when you publish data, you can publish data with confidence and you don't have to because backfilling that gets very crazy because then it's like, oh, we have to just like if you have a very important table that publishes bad data and then it gets proliferated, you essentially have to backfill the entire warehouse for a day. And so it's like, oh, now we just got to double up on our warehouse compute for a day. And it's like, that's expensive. Like it's really expensive, especially from an IO perspective. It's very expensive. So I want to just talk about an example here. So there's a table called dim all users at Facebook, which, you know, the table I was, those pricing and availability tables I was talking about that had like 1,000 downstreams. Dim all users is another level, a whole other level. It was like 10 or 20,000 downstreams, where what ended up happening was there was a migration to a new compute engine, and it actually ended up breaking this contract and kind of ignoring the contract completely. And then bad data was published, and then it was picked up by 20,000 downstream pipelines. And then we had to then it's like, as data engineers, we have to figure out how to fix that, right? That's a big nasty problem, and like it becomes like it completely derails your other development, right? And it's like, wow, I have to now figure out this big giant data quality mess instead of like actually doing my job of like building new pipelines and adding new features. We have dim all users, right? And so what we have to do there is we essentially have to find all the pipelines. So we have to fix the bad data and then find all the pipelines that pick that bad data up and then run them again, right? Because keeping in mind in those cases, like you can actually have not just secondary pipelines, but you can have tertiary pipelines where your bad data is picked up by another pipeline, which is then picked up by another pipeline, right? And then you have to think about, oh, what about the tertiary impact of bad data? So the main thing I'm trying to nail home here with y'all is like, if you are working with data sets that are heavily used throughout a big company, you have to do this. You have to do this, like, because if you don't, and you have, and this happens twice, where you publish bad data twice, you're gone, you're fired, done, get out of here. Like it's too expensive. Like in fixing that problem for Facebook probably cost them almost $1 million, right? So it's like not worth it, right? Follow these contracts. These contracts are very important, and we're going to be going over how to do one of these contracts in the lab today. So if you have a bad metric definition or you filter down too far, things get noisy. They get very noisy, and like so you can't do data quality on like metric definitions that are too narrow because you the problem is you get to a point where normality doesn't exist anymore. So, my comical one here is knowing the engagement per qualified minute of Ethiopian children who use 7-year-old iPhone devices on Christmas Day is going to be a noisy metric, right? Because like that's a lot, right? That's a lot of cuts. And like what does qualified mean? Like qualified minute, okay, like that has its own definition and its own set of metrics, right? And then you have like, okay, like 7-year-old device, that seems pretty narrow. And so like when you're coming up with metrics, like they should be pretty broad, and you can get away with like one or two like dimensional cuts. You might be able to do like female iPhone users, or like American iPhone users, or female Americans, or you might be able to get age in there as well. But like generally speaking, like you want to have like your metrics and like where you're throwing in your quality checks on your metrics, you can't have them be so narrow because like there's going to be like, well, because in this case, well, maybe there's only 7 Ethiopian children who do this, right? And then then the next time around there's 5, and then it's like, oh, it goes from 7 to 5, and then people are like, wow, a 30% drop, holy crap, right? And like your thresholds are going to be all funky. And so that's a thing to think about when you're like thinking about metric definitions, is like you got to be careful, right? A lot of this is common sense, like, and like obviously I'm trying to illustrate this in a very comical way where like this is not a metric definition that y'all would probably come up with, but you might have come up with one that is like that sounds smarter, right? So but that's the idea, is like it's the same thing like if you're trying to look to get married, and it's like, oh, I need a man who's like over 6 foot tall. He makes over six figures, right? He lives in San Francisco. He plays guitar, and like once you have like 5 or 6 or 7 criteria, like you're down to like 5 people, right? And like because that's just how like dimensions work, right? They become more and more unique as you throw in more of them. And so like you want to be careful when you're coming up with these metrics, especially with dimensional cuts.